Hello everyone, I'm Lavanya. I'm currently practicing at JSS College, Mysuru. In this video, I'll be presenting about high pressure liquid chromatography, which is also referred to as high performance liquid chromatography. So first we should know what is HPLC. So it is a technique used in analytical chemistry to separate, identify and quantify components in a liquid mixture. So HPLC is modified column chromatography. In column chromatography, a column is attached to absorbed material like silica and mobile phase is passed down due to gravity. But in HPLC, a high pressure pump is attached to column, so it can generate high pressure up to 40 MP. So HPLC relies on the difference in how compounds partition between the mobile phase, that is the solvent, and the stationary phase, which is the column packing. We will see in the next slide about the separation principle. The mobile phase, that is the solvent, is forced through the column under high pressure, and compounds that interact more strongly with the stationary phase, that is the column packing, will travel slower through the column compared to those that prefer to stay in the mobile phase. So the column is filled with adsorbent material which have very small particle size, large surface area and high resolution. So it is usually made up of stainless steel which can withstand pressure up to 50 megapascal. So the length of the column will be 5 to 25 centimeter and the internal diameter is 4.5 millimeter. So the flow rate of mobile phase to column is 1 to 3 ml per minute. The stationary phase used here is usually chemically modified silica, divinyl benzene, etc. The particle size of the stationary phase should be kept uniform to obtain better performance. So the mobile phase. The mixture of different solvents can be used as mobile phase. So the solvent used depends on sample molecules which has to be separated. The mobile phase solvent can be polar or non-polar and it is usually kept in solvent reservoir. Slide. So HPLC uses high pressure to push the mobile phase through the column which allows for faster separation and higher resolution. So we will see about the detection and chromatogram in the next slide on the instrumentation of HPLC. As shown in the figure, HPLC instrumentation includes a pump, a injector, column, detector and acquisition and display system. The heart of the system is the column where separation occurs. So the mobile phase is usually kept in solvent reservoir. Solvent reservoir is attached to the high pressure pump which the mobile phase is pumped into the column with high pressure. So you can see there before HPLC column there is a sample injector. In order to detect the elute, it is attached to the HPLC column. Detectors such as UV visible detector, fluorescence detector or mass spectrometer is used for the measurement of the concentration and other properties of the compounds. So the output of the detector is a chromatogram, which is a graph showing the concentration of each compound versus time. So the peaks in the chromatogram corresponds to the separated compounds and the area under each peak is proportional to the concentration of that compound. So this is about the instrumentation of HPLC. Moving on to the next slide. We have two types of HPLC, normal phase HPLC and reverse phase HPLC. So normal phase HPLC is a chromatographic technique where the stationary phase is polar and the mobile phase is non-polar. So it is used for separating polar compounds as these interact more strongly with the polar stationary phase and elute later. So conversely, less polar compounds interact more strongly with the non-polar mobile phase and elute faster. So another type is the reverse phase HPLC. So it is a method of separating compounds based on their hydrophobic interactions with a non-polar stationary phase while using a polar mobile phase. So this technique is widely used for analyzing and purifying biomolecules, particularly peptides and proteins. due to its ability to achieve high resolution and excellent reproducibility. So next, uses of HPLC. So HPLC is used in purification of water, impurity detection in the pharmaceutical industries. Trace components are pre-concentrated here, and chromatography based on ligand exchange, protein chromatography via ion exchange, carbohydrate and oligosaccharide anion exchange chromatography at high pH. So moving on to the applications of HPLC. So we have used HPLC in various fields, like we are using here for drug evaluation, synthetic polymer analysis, pollution analysis in environmental analytics, drug determination in biological matrices, isolation of high value goods. Now it's time to conclude. So HPLC is a type of column liquid chromatography that has been greatly improved. Instead of allowing a dissolvable to flow through a column under gravity, it is forced to do under heavy weights. As a result, it is substantially faster. So this is about HPLC. Thank you for your time.